three main robots, the robot recorder, and the two RoboFast. We are the sixth graders from the RoboFashion junior team, and we want to perform music and dance using robots, and we want to learn speed through robotic activities.
So this is our whole setup. It consists of 4 robots: the pumpkin robot, which flies the recorder in the air, and the big robot, which plays the keys of the recorder, the ballerina robot, which spins around and sends and receives Bluetooth messages, and the duck robot, which dances.
Okay, so we have the 4 robots. The duckbot starts the entire program by touching the touch sensor mounted on the ballerina bot. The ballerina bot, once it gets the signal from the touch sensor, it sends a Bluetooth message to the pumper bot, which then sends a Bluetooth message to the finger bot. Once every robot is running, the robo recorder will play Mary Had a Little Lamb twice. Once it plays Mary Had a Little Lamb twice, the finger bot will send a Bluetooth message back to the pumper bot, which will then send a Bluetooth message to the ballerina bot, which will touch the touch sensor mounted connected to the duck bot. And then once the duck bot senses that everyone is paused, it will restart this entire communication loop, and then the robo recorder will play Mary Had a Little Lamb again, but this time faster.
Hello everyone, we are the Creative Canucks, and today we will be presenting to you a piece of drama that involves dancing, sculpting, and various other sorts of arts. Here I have 2 characters. We named our 2 robots. Right there, for the normal MNC, we named it Captain Poutine. Poutine is a food from Canada, so we decided to put it in our robot name, and this is Sir Beaverlot III.
So this is sort of a play. So one winter morning, the 2 friends, Captain Poutine and Sir Beaverlot III, were building a snowman to celebrate the winter. Sir Beaverlot III celebrated very joyfully because they succeeded.
Captain Poutine got lucky and decided to take the snowman away from Sir Beaverlot III while he was celebrating. Sir Beaverlot III finally sees Captain Poutine, which is on.
After a long chase, Captain Poutine decided that friendship with Sir Beaverlot III was worth 10,000 stones. He decided that he would rather be friends than enemies. They talked it out and celebrated together. Everybody join us to a celebration.
Introducing performing
A parody to Just Give Me a Reason by Kinetic. I give you Steve the Second and Bob.
Can you shift this one? Oh, thank you. Thank you.
Bob's guitar, Steve's hair, and the lights were put up and made by prop manager number 1, Julie. Stage, music, and introductory slideshow were provided by prop manager number 2. We use a text sensor to start and stop both robots.
We'd like to thank MCWT as they received a grant for being an all-girl power team.
When we first got here, the ground was too hard, so we had to remodel our robots.
So what this robot does is we place the ball right there, and then we press the button, and then after 3 seconds it goes down, and it goes back up, and it goes across this, and lands on this, and then it goes across and lands in the dog.
This is our program. Over here we have a touch sensor with a switch. So it moves the steam motor half rotation down with the piston moving the plate downwards so it can go down and slide down there. Then after 3 seconds it moves back up, back to its original position. And we have a parallel line sequence the whole time going, this thing going forward.
So this will be used in the real world for transporting goods and as a assembly line.
Hi, we are the Circle Robotics. I'm Dave. I'm here deciding and building the XY table on the road. I'm Lilia. I learned a lot and we have to figure out how to convert the pressure to the angle for the brush, and I enjoy programming the color palette robot. From here is our robot. He is a left and right brain robot. The right brain is more creative and artistic. Each of Frank's masterpieces are unique. Every artist has his own way of creating art. Frank has his technique, and it's all about the pressure you put on the brush. But it's the pressure that you give Frank through the range of types of pressure sensor. The harder you push, the more pressure the brush puts on the paper. The left brain is a mathematical analytic. Frank makes his masterpieces using an XY table. He uses the XY table by using the programs are then solved out of it. And he paints them and he starts to move from one point to the next. Historical data next for you. To begin, you have the following choices. R, A, F. R, from Campbell, four letters, so we don't have a choice. Before painting, you choose a color card and show them about the color card. Lola selected A or from. She chose the color blue. The robot will rotate the palette blue. The palette then communicates with Prompt through Bluetooth. He tells Prompt that okay, great. And Prompt brings the push, the brush to the palette. Prompt starts painting at the first XY coordinate from the tile from the chosen shape. He will continue through all the coordinates until the image is complete. While Prompt is painting, and controlling the pressure of the brush through when Prompt is ready. He will return to rinse his brush in the water. This is Chris, and in the craft team we have me,
Graham.
and Jimmy. And this is our robot. It draws common shapes such as circles, triangles, some unique shapes like stars. This is some information about our team. This is the QR code scanner in case if you have a QR code on your phone. This is what the programs do. It sets both buttons are pressed. It tells it which way to go. If only one, it says, go to this or do that. And the other press tells it to stop. And here's how it works. Here's a remote program. So yeah. And that is the remote control program. It can do any unique shape. And this is the everlasting circle.
Hello, my name is Will White. I'm in 8th grade and I've been homeschooled all my life. I've worked in creative robotics. This year I decided to do the Cyclone 2 robot. I'm actually following up on a student at North Tech University's work. This is his original work, but then what I did is I basically just added more supports onto it so it wouldn't fall apart. But also right here, I added a color sensor and a sound sensor so that you can just knock on the table, then show a blue color onto the sensor. And then what happens is this motor lifts up so that the ball rolls down. After that, this rolls up so the ball goes down through the entire cycle and that stuff right here. So I'm going to run the program for you. You want me to go and start it? Also, what we figured out is that if we can, on the walls, we can paint some sort of logo. We chose to put a graph on here, and it's been displayed at the North Tech Showcase for about a month now, and we've been advertising graph for a while. slide this back and forth. And this infrared sensor sees this, go back and forth, and then depending on the distances, it plays a note.
Put the mic down. Put the mic down.
So what we decided to do, since it's earlier Christmas time, is we programmed it so that it would play jingle bells. Another thing is, since we figured that wouldn't be very space efficient to have a finger on each note of the keyboard, we put wheels on it so that we had to figure out in the program how the distance it had to travel for it to play. I think that for this robot, it only has to play one octave. It plays all these 6 notes. A, B, C, E, E, F, G, A. So, do you want to move over?
I'm Molly Pellet, this is my brother Max, and this is our graph project. I was mainly the designer of the Robotic Creation Center, which I'll tell you about in a minute. Max designed most of Margot, and I helped him build it, and he also programmed Margot. So the Robotic Creation Center is a concept of an idea of a museum that could exist. There would be 3 galleries: the Kinetic Art Gallery, which would have moving art, sculptures, wall art, or art created by robots, and this would give robotic artists a place to display their creations. There would be the Kinetic Art, or the Interactive Art Gallery, and you could interact with robots there. You could build your own robotic creations, or interact with ones that were already built, maybe have a conversation with a robot, or make music with robots. And one idea that we would like to have there would be a robotic color wall. So it would be a wall that has a whole bunch of sensors on it, and when you moved in a certain way, it would change the colors and patterns and shapes on the wall. The 3rd gallery is an educational art gallery, and so robots can teach lots of things, including Newton's 3 laws of motion, graphing equations, scientific principles, and history. It's a lot easier to understand things like the Heisenberg uncertainty principle if you can see a robot demonstrating it rather than just reading it out of a textbook. So the robot that we have here today is named Margot, which stands for Moving Art Robotic Grid Operation. Margot is a work of kinetic art. A robot like Margot could be found in one of 2 galleries, either the Kinetic Art Gallery, because he's a moving art, or the Interactive Art Gallery, because as some of you did, you can design patterns and we'll display them on Margot. We built and designed Margot using a BioLite Premium robot kit. We chose to make the white lines out of playing cards because they were sturdy but still flexible. Our original material was index cards, but they bend too easily. And we plan to use a 3D printer to print lines that are curved. We have a little picture so that they don't get caught on each other as easily. Sometimes they still get caught on each other. Because Margot is built using 16 motors, she's a great example of robotic kinetic art. She also includes a distance sensor to detect if someone has walked up to watch her move, which is similar to concepts that would be in the Interactive Art Gallery. We're able to switch between sensor mode and automatic mode for demonstration purposes. Sometimes it's easier to demonstrate with the automatic mode, which just loops through our cabinets. Margot is programmed using RoboPlus Task, a programming language that was designed for the BioLite Premium kit. We input design patterns manually into the software used to create motion files, which is called RoboPlus Motion. We can change the amount of time each pattern is displayed, and we can add more patterns to the loop by simply changing one number. So if you haven't already, we'd love it if you design a pattern for us to display on Margot. We have forms and you can draw a
Okay, so what we have here is a series of cams, and linked up to the cams is these pipes, and they're activated by putting your hand in front of these sensors. And as you can see, if I put my hand in front of this sensor, this corresponding motor will turn on. Same thing with the rest of them. And the idea behind this is that it's supposed to look sort of like an engine almost type of design. As you can see, there's cams, sort of like how in a car you have a camshaft. And then the lights above, currently they don't correspond to anything on the rest of the robot, but we have in the past made a system where a dot will appear only above the motors that are turned on. So that way when you go across like this, it will follow your hand, and it will appear as though it's a sine wave going up and down if you're in the dark, for example. So that's the idea. That's the main idea behind our robot. We hope to explore more ideas on this in the future.
Hi, good evening. I am Roberto Sali, Kinetic student. We want to do a robot to help the world. We want to go beyond the art. We want to create something that could be better for society and we live.
We decided to create a thing that related music, emotions, and art. And after a whole discussion, we came to the idea to create a keyboard that will paint with an electric robot arm.
Well, to do so, first we need to fill with the database that consists in the relations between colors, shapes, and emotions.
After that database is filled, you have to play the keyboard, and then the keyboard relates what you played with the database, and after that it gives you a result of what the database gave. But this isn't 100% correct, because every mind thinks difficult, but it's a percentage.
Well, once you play the piano, the robotic arm instantly starts painting some shape with different colors related with the color of the emotion that the database throws, and it starts to paint so we can know what is the motion that he represents touching playing the piano.
We made a complete wire system. It's behind this cardboard, and we were 2 months working on the robot and in the programmation.
Well, we are going to show you a brief demonstration of what those robotic arm does. Now we are going to spray the ink to see how it will be when it finishes. he will shut the ink to